Hey, I want to make this quick video and go over some stuff. I've had some tolerance issues because I wasn't paying attention, so I want to go ahead and explain the printer tolerances, why they're important, and how to use the tolerances in your designs with Shapr. I also want to talk about why I use millimeters rather than freedom units, and how, if you were raised on inches and feet and miles, how to think about millimeters to make that transition a whole lot easier for you, and how to apply the tolerances and the millimeters to your design, and how to use them as variables in Shapr3D. Basically, when you're 3D printing, different materials will perform differently. I think some of that we'll see when we get into the Z depth layer and the strength, and then the expansion of that. What bonds one layer to the other, because the nozzle is round and it's moving. So every morning you have a nozzle that's round and it's moving. It's your toothpaste, right? And when you squirt it, it doesn't stay perfectly round. It smushes out, right? So this stuff is under heat, it's under pressure, it's bonding to the other layer, and it's really small. But don't think of these, and you use round filament, so you think everything's round. It starts round and then it ends oblong. And we want to know how oblong it gets, right? How wide that gets when it squishes out like on a tube of toothpaste on your toothbrush. And is it a lot? Is it a little? Because the more it is, the more I have to design for those tolerances, right? There's a gnat in here. I added some plants. I added some plants to try to filter up the air and make it a little greener in here. And they're brand new plants, and there's two gnats that I haven't caught yet. Anyway, to do a basic tolerance test, do the round one and the square one. Do the one that looks like this. There are a lot of bridge tolerance tests and arcs, and you really don't need those for basic design. It's nice to know, but it takes forever and it wastes a lot of filament. So I typically just do a quick one. The round and the square one are great. And then I pretty much treat all the PLAs the same. I treat all the ABSs the same, and so forth. And on the exotics, and I consider anything exotic if it's over $75 for half a kilo, or $75 for 1 pound of the stuff. And that I will do, like on this PA-HTCF. I'll do it once, and then I'll assume every PA-CH, nylon, high temperature carbon fiber that I get from bamboo will be pretty much the same as that. I'm not going to waste money on those. And same thing for PLA and ABS. If something's printing with different, like maybe a blue is different than a green, I haven't seen that, but if it is, go do a quick tolerance and see what happens, or print a different color and see if it fixes it. Let's see. I pretty much do everything in PLA, ABS, and PA-HTCF. If I'm prototyping it, and I need it fast, and I just want to get my hands on it, that's PLA. If I need something that needs to be durable, but I'm not in a rush for, and it doesn't need to be super durable, I'll do ABS. And then if I need something that's just a crazy exotic strength that looks good, I'll do PA-HTCF. I do have the other items, PPA, PPS, rarely use those. I'm not saying I don't use those. They're just not my go-tos. Those are when this stuff doesn't work, and this stuff works most of the time. If we look at it, the toughness, PLA is a 26, ABS is a 39, PA is a 57. Strength, PLA is a 76, ABS is a 62, PA is a 125. Stiffness, PLA's 2,750, ABS is 1,800, PA is 4,200, right? So PLA is not bad, but the problem about PLA is the heat. It can only get up to 57 centigrade, where ABS can get up to 87 centigrade, and PA can get to 194, which is crazy hot. And then your Z layer adhesion. PLA and PA are about the same, in the 13s, 14s. And then ABS is around a 7 or 8. So ABS is when you need it to be a higher temperature than PLA. but they're both pretty much about the same. ABS works just fine for most things. If you were to take the sell price of buying multiple bundles and get down to the cheapest price you can get, and then you went and looked at the spec sheet and looked at the diameter of each of them, the volumetric density, and you calculated the nozzle diameter, and you did a bunch of math, because they sell it by the kilo, but each kilo, PLA and ABS have different volumetric densities. So what does that mean? And what that means is PLA is about 3 cents a meter, or 3.3 cents a meter. ABS is about 2.8 cents a meter. So for every meter, you're looking at throwing 3 cents on the ground or less, right? PAHT, which is the least expensive of all the exotics and works in an AMS, right? You're looking at 19.4 cents. So you go from 3 cents a meter to about 20 cents a meter. And, you know, depending on how many meters of this stuff you're using in your job, that adds up pretty quick. And that's all with the same size of nozzle and everything. So what we want to do is we want to, this is, and I write down on the back, right? This is ABS with a 4.0, a 0.4 nozzle, 0.4 millimeter. And here's a 0.25 tolerance, very slippy, 0.20 slippy, 0.5, 10, and then right there, about 0.05 is what I would call slippy, because you can hear it grinding. And I do the 0.1 as super slippy. And then anything less than 0.5, I'd consider tight, right? So I don't need all these. I typically think of things as, I want to slip past super easy. I don't want there to be any resistance. I want to screw it in and screw it out, or slide it in and slide it out, and hear a little bit of friction. So if I let go of it, it will stay. It won't just auto spin on. And then tight means it'll go on once and probably not come out. And a little CA glue, and it's not going anywhere. So you see that the ABS, right, and they also do one for the round. Sometimes rounds are a little different, right, that it's tight at 0.5, right? I can kind of get that through there. And if we look at PLA, right, we're getting slippy, friction, tight. So on the PLA, we're seeing 0.5 tight, 0.1 slippy, and 0.15 super slippy, right? Now, we come over here to the nylon, which has a great Z-layer adhesion, and 0.05 won't even fit. 0.1 won't even fit. I mean, this stuff squirts out and gets pretty wide. So you don't even start getting into the tight, right, until 0.25, which would make, you know, 0.3 slippy and 0.35 super slippy. So that's a hell of a tolerance right there. I can't even get it out, right? So for some of your exotics, you might want to go a little bigger on the scale, because I cannot even get the round one or the square one in on 0.2. And, you know, that would just fall. 0.2 on ABS, it'll just fall straight through. So know what your end product is going to be. It's going to impact your design, but we can use variables, and we can take care of a lot of this in the design tools. Now, if you're like me and you grew up on Freedom units and you're struggling with millimeters, the best thing to do is make a fist, right? And we'll use miles per hour, we'll use Freedom units and everything, but I hate, oh, now I'm gonna have to edit this out. So the reason I don't hate inches, but I hate fractions, okay? Fractions, if you told me that I had to take 1 and 31/64 and add 3 and 7/8, and then subtract 3/4 of an inch, and then add 5 and 9/16, I'd want to blow my brains out. So that's why I like millimeters. And they're just easier to work with. And I'd rather have 19 millimeters plus 2 millimeters plus 0.5 millimeters and know exactly what the answer is going to be. I said make a fist because this, you know, if you're going through the lumberyard, this is 2 inches, this is 4 inches. You can go up and say, okay, that's a 2x6, this is a 2x8, right? And you can really quickly figure out in the neighborhood what you're dealing with. And so I like to think of a fist as 4 inches or 100 millimeters. So let's just get the old calipers out and let's get them to 100 millimeters. 100 millimeters, or what is that? That's going to be 3.9485, basically 4 inches, right? And you see how my fist basically is 100 millimeters, right? Get that back over to millimeters. So you don't have to, it's actually 3 inches and 121st over 128, which is crazy. So 100 millimeters, 4 inches, right? One fist. 50 millimeters, 25 millimeters, 75 millimeters, right? So you can use your hand and do some quick maths and kind of get like how big it needs to be. Is it a handle for something? 100 millimeters. Does it need to be about this big? 200 millimeters, right? And if you just make a fist and think of it that way and measure how big your fist is, you'll be good. And that way you can divide it by 4, you can do all this stuff. Makes life a lot easier. Or just go buy a caliper. I have calipers within 3 feet of me of all time when I'm doing this stuff. Okay, so now that we've went over how to get your tolerances, that you just need a simple basic tolerance test. Do it for each material, write it down in a book once you've done it, and then we're going to take it from the book and we're going to put it into Shapr and use it for our designs. And we're going to go through multiple materials without having to redo everything. So I'm going to show you how that works on the iPad here in a second. Let's switch screens. So cool, thanks. Bye. Okay, so we're going to use the variables for our tolerances. So we want to come over here and insert a variable. And remember I said I use tight, slippy, and super slippy. So we're just going to go with slippy here. And let's say that that offset was 0.15. All right, so that variable's created. We should be able to go over here to history and we should be able to see that slippy is 0.15. So yep, variables there. I wish they are global variables to the project. I wish there's a way to go in universal at the Shapr admin level of the entire tool and set variables there so I wouldn't have to enter them in each time, but anyway, that's a different problem. All right, so what we're gonna do here is something super simple. We're just gonna do a bottle with a lid. 100 millimeter diameter. Take that, we're gonna extrude that up to 100 millimeter, right? And then we're gonna shell it 2 millimeters, which is 2 millimeters each side, right? So, I think that's what I did. Did it do 2? Yeah, it did 2. So now if we measure this, it's 96, right? Because you took 2 off each side. All right, now we need a lid. And the lid needs to have the tolerance added to it to be able to fit, or removed from it in order to fit. Because if we did it 0 line and 0 line, it would not fit because there's some squishy outiness. And so what we want to do now is let's do another 100 millimeter for the lid. 100. All right. Let's extrude that up a little bit. Let's do 3. All right, and now let's offset the edge by 2 millimeters. Now if we do that, it's going to bring it into, and then it won't fit because it's squishy. So we want to have -2, and then we want to add the offset, which is negative slippy, right? So -2 plus negative slippy, because we're going inwards. If we're doing it on the other side, we'd go backwards, right? And you can see that made the function result in -2.15. And then we'd come out here from there, and we'd select this, and we'd come up another 2 millimeters. All right. Let's make it more than that. Let's make it total length 6. All right, there we go. A 180. That flipped completely around. Move it up. Use our translate tool. And then that make it perfect. So I need to raise that up a little bit. Say 3. All right. So there's the lid. But what the offset did, let's see what this is. And I'm using the section view, right, where we're slicing it. We can see that slippy is going to be, it's not going to be exactly perfect. But what happens is we know that it's going to grow 0.15 when we print it, and it's going to be a pretty good fit at that point. So the project's all done. We can send this to the printer and let's say an ABS or PLA, it'll be fine. Now, let's go back and say that we want to do it with PA-HTCF, right? Because that stuff, was quite a bit, it squished out a lot more oblong than the other ones. So let's go over to history, and let's go to slippy. Oh wait, and select, all right, go to slippy. And what did we say that was gonna be, like 2.5? A much bigger hole, right? So we changed the variable there. And then, translation, movement, face offset, extension, sketch, extrusion, shell. We see that this is now -2.25, right? So with the parametric model, we can see that this is more of a gap now. And that would be great for PHAT. And let's say, I don't know what we're using, something super crazy, 1.1, right? You see how the gap grew? Let's make it 7. See how that gap has grown? And that's our tolerance. So we know from our tolerance tools what the tolerance needs to be. And as we go from material to material, we can just change that to say, all right, let's have it be PLA. And now I need to make a different one. I need to reprint this one for PHAT. And let's make that 0.30. I really want it to, you all to be able to see that change. All right, make that 2.0. So it was 0.15. Oh, 2 decimal points. 0.5, right? It had a very fine tolerance. And then if you watch this area right here, right, you can see it get bigger if I go to the 3.5. And you don't have to redraw anything. You can just use your parametric, and you can use your variables and just change your variable at the very beginning, and it'll translate all the way through. So always set your variables at the beginning for any tolerance items you'd have, and then you'll be good. Now, if I was going to actually send this out to the printer, I might even save myself a step and think about orientation, all right? And then it would look something, I'd want to print this just like that from the bottom up, and then this one I'd flip upside down, and that way I wouldn't have to have any supports, and I would just print it just like this, and then it'd be fine. So super easy to use variables, super easy. Remember, you just come over here under insert and a variable right at the beginning. I always make it a number. You can do the other things. It doesn't really matter as far as I found. And then change it at the beginning. So hopefully this helps. Hopefully this makes sense. Hey, hope you enjoyed the video. Hope you learned something. If there's anything you want to see, anything you have questions about, anything you think my math is wrong, please hit me up. Hit me in the comments and we'll get you addressed. Thank you very much. Take care. Bye.